12 hours early almost. Hello, everybody. It is not 1:30 at night like it has been. So I'm done with the interview. I got the job offer. So that's good. It's good, but I don't know. I'm kind of wrestling with some other things. I'd like to. It's a normal job. It's a normal, steady, and by normal I mean like it's a steady, basically 8 to 5 job. It wouldn't be those exact hours, but it's a 40-hour full-time job. But like I would love to make my own schedule. Like I would love to be able to, I'm an editor. I make videos for people and stuff, and I would love to be able to do that for my job. Like normally, I do that, and I've done that a lot. But I would love to do that as like that's my shtick. I don't have another thing going on like the normal job or whatever. I'd love to do that. So I'm wrestling. I'm sorry to get into all that. I'm wrestling right now. I need to pray about it. But so I did that, and then I got some editing. Speaking of editing, and got some editing done. And we're gonna do this now. I have some editing left down here. Have some editing left, but hopefully that won't take too long. But to this, we're gonna run through. Can we hear it?
So now we're going to talk a little bit about.
Yes, we can hear it. And by we, I mean you guys, because last night you couldn't hear the majority of this. So what I'm going to do today is we're just going to let this run. I won't stop it or anything. We'll just run through it. It was a bit confusing anyway, so it wouldn't be bad for me to watch this again. We'll go through this, answer the question, move on, and we'll do the next video today. So that's the plan. Let's do it.
So now we're going to talk a little bit about XML schema. XML schema is a language that allows you to decide on whether or not a particular XML document meets a contract, an arrangement. So you have two pieces of software exchanging data using XML. And what if one of them, if they're all working, nobody really worries too much about it. But if all of a sudden one breaks, you change one side and the other one breaks, whose fault was it, right? Was it the side that got changed or the other side? And so you could argue. So what you like to do is before you set up these arrangements between these applications, set up a contract. In a way, they're kind of like the RFCs are, except that their scope is between pairs of applications. And so it itself is XML. And it basically, what we do is we take an XML document and an XML schema contract, and then we either say that's good or that is bad. And that's called validation. A piece of software that validates XML when given a schema is called a validator. And so an XML document, here we have our little XML document, we're passing it to the validator, and then we have a schema contract, which is itself XML. It's kind of a particular kind of XML, that XS colon complex type. That's just a tag. Colon is a legitimate character for the name of a tag. Name equals person, that's just an attribute. And so XML schema is a particular format of XML that renders an opinion about what XML is supposed to look like. So there's a number of different XML schema languages. The one we're going to look at is one that's kind of came a little bit later, that's very common, called XSD, which is the World Wide Web Consortium's schema specification. Often you'll find files that have suffixes of .xsd that actually contain the XML, just like we're going to show you. So if you recall, there are simple elements which have text children, and then there are complex elements where other nodes are children of other nodes. And so we can say this. And so here we have a little bit of XML and the XML schema that makes sense with that. So what we're saying is the outer tag of this legitimate XML is supposed to be a complex tag with a name of person. And so there we go. That looks good. Good, good. Then there is a sequence, and then there is a simple element, a name of last name, looks good, and it's a string, that looks good. Another tag that's of a named age that's of type integer, that's good. And then a thing that's called date born, and then there it looks like a date. So we check all these things, and we can basically say, yup, that is a good XML document according to this schema. And you don't have to write this generally, but there is software that reads these two things and comes back with a true or a false, and might even have some detail as to what went wrong with this particular schema. Here's some more that you can do with a schema. We can do things like, have a complex type, we have a sequence. Here we have a string, full name, and a string child name. But we have this min occurs and max occurs. So min occurs is the minimum number of times it can occur, and maximum is the maximum. So min occurs equals 1, max occurs equals 1 means it's required. And so this is required, and we don't have two of them. Two of them would be an error. One of them is fine, so that's good. Here, the child name is min occurs 0, max occurs 10. So we have 4 here, and so that's good too. And so that is another kind of XML schema constraint that you can have. Here's a few other data types that we can do. We've done the string, we've done the date. The date looks like this. Dates are 4-digit year, 2-digit month, 2-digit day with dashes. Now there's lots of different ways to represent dates, but the nice thing about this, and you have to put the zeros in, so 09 for September. It means that these are sortable as strings, so that if you do all your dates this way, they're sortable as strings. So you could argue what is prettier, but for computers we don't worry about that. We're arguing about what's the most functional. And then the date time is that same date format with zeros, followed by the letter T, and then followed by hours, minutes, seconds, 0 filled, right? So 9 o'clock is 09. And then the time zone, which we'll talk about a second in the next slide. You can have decimal numbers and you can have integer numbers as well. And so we are able to sort of render an opinion as to what is good and what is bad in the resulting XML. So dates are kind of interesting. There's, again, we have lots of different formats of dates, 9, 10, 9/10/2002, right? That's a format of a date, but that's one. There's another format of the date, which is 12 December 20, whatever. And so this is how people show dates. Computers don't want to have all those different dates and don't want to figure those out. They have libraries that produce dates and make them look pretty for particular locales, but computers really want dates that work best for them. So we just say, okay, we're going to have this year, month, day, time, and then 0 fill, hours, minutes, seconds, HMS, and then time zone. Now, computers even prefer a time zone. I don't know if you've used something like your Google Calendar and you take a flight or take a train trip and you end up in a different time zone, everything switches. And that's because Google Calendar is not really storing the time zone that not storing the dates relative in your current time zone. It's storing them in what we call universal time, or Greenwich Mean Time. Zulu time is another word for that. And Z means this time that is the time in London, England, Greenwich Mean Time. And so the thing is that means if this data moves between time zones or crosses the international date line or standard daylight savings time or anything like that, none of that changes. And so we have this internal date and time that's very common in situations where computers are exchanging data that then gets shown with a time zone, converted to the time zone or the local format. That's the right way to do that. And there's a standard for how dates and times are supposed to look. So here's another little example of some stuff. Let's see what we got. Now, if you see this little question mark XML, that's not a problem. That just is a way of sort of putting a header on the whole document that says it's an XML document, telling it that it's a UTF-8 document. And that's not really a tag, that's sort of like a marker on the file, so that you can put that there, but it doesn't harm the XML. The outer tag is this tag right here, XS:schema. And then what else we got? We got an address, we've got a string, we've seen all those. Here we have country, and we're going to have a restriction that basically says this is a simple string, but we're going to make it so that you have to list one of these 4 as the country code. And so here we are down here, and that's UK, and that's UK, and so that is valid XML. Another couple of examples here. Let's see, string. Max occurs unbounded. That means infinite number. There's no limit on the number. You can do that. Min occurs of 0. XS positive integer. We've seen integer, but you can also say it's got to be a positive integer. Decimal, we've seen that. And then use equals required is just another statement that you can make. I'm not trying to get you...
Hold on a second. I am getting a call. I don't know who this is. I'm sorry. Okay. That was the interview thing. I just need to do something really quick here. Hold on. There we go. Hold on. Waiting for this code to be sent. I'm sorry. I said I wanted to stop the thing. I wasn't expecting to get a phone call. What if I try to do this through? But I'm so sorry. I'm so unprofessional. Need to do this though. Okay, hold on. Okay, here we go. Let's try this. There we go. It shouldn't take very long. And there we go. Do it. I think I did it. I think I did it. Send off a text. All right. There we go. Where were we?
To the point where you can do XML schema, just get you a sense of the kinds of statements that we can speak about when we're talking about what is and is not legitimate XML. So let's talk a little bit about how we might talk XML inside Python. And so, like most things that are in this extended part of Python, we have to import something. And so this is the name of a library, XML eTree element tree. And then as ET, this ends up being a shortcut. So we don't have to type these long things. And so ET is the same as typing that. It's almost like a macro. Now, normally this XML is going to come somewhere from the network, but I'm just going to put this in a string. I'm using a triple quoted string, and so that means that this triple quoted string starts here and ends here, and all these new lines that are here are actually part of the string. So this is kind of like I opened a file and read the whole thing in. But just to keep this totally self-contained, I'm putting it in a string. So the XML would come from some server on the other side of the network. We would get this XML. So that's how it would normally work, okay? So this is the XML right there. And we parse a string of data, and we call ET from string. So we're passing in the less thans, the new lines, the greater thans, all of this stuff we're passing it in. And this could have syntax errors in it. So this might blow up if this had a syntax error, like we forgot the little slash or something, there was a syntax error. But this doesn't have a syntax error. So then what we do is we get back an object. I just happen to call it tree because it kind of is like that tree version of the XML. That is an object that we can then query to pull data out of it. So we say tree.find and look for a tag name name. So that finds the tag name name is this. It's everything. It's the tag and the text. If we want the text, we add .text, and then that .text, that actually refines it to only the word Chuck. And similarly, if we do tree.find email, that tree.find email, that finds the email tag, which is this tag. It has a child attribute, and you can get any of the attributes. You say .get. There's only one text child, but there are many attribute children, and so you have to tell it which one you want. And so this bit right here, all of that will resolve down to that string yes. That's what you're going to get there, yes. And so you kind of build up these little finds and call methods. This is not clearly a full introduction to element tree, but you get the idea that you sort of dive down in with these methods that call methods to get little pieces out and parse all of that. Here is a different example. In this one, again, we're using triple quoted string. We always have a single tag on the outside, and then I have a complex type of users, and in it there are two user objects. So this is kind of like a list, right? So this is more than one of these things. So this user can occur more than one time. And again, we take this, we pass that into from string and get back an object that represents the name stuff. Does not necessarily have to be the same as this outer tag. Just a variable. This could just as be easily as X if I wanted. So now what I'm going to say is, hey stuff, I want to find the tag, the path, users/user. I want to find all tags that match users/user. So that's going to give me a list of two tags, one tag, two tags in a list. Tag, tag. Oops. So two tags. Now I can print out how many I get. That'll be 2 in this case because I got 2 tags. And then I can actually iterate through the list. All right, so I can iterate through the list. So this item is going to iterate first to this tag, and that tag, now it's like in the previous example, we can look for the name tag within there and pull the text out. So we pull that text out, find the name tag, and then within that find the text. And we can find the ID tag and pull the text of that out. So that pulls out this 001, and I've scribbled too much. And then we can item, which is, this is item, is that whole tag, .get X. So that gets the attribute, that gets the 2. That 2 comes down here. Okay? And then item goes to the next one, because item is looping through, so item iterates down to that one and pulls out the name.text, the ID.text, and the attribute.x, and pulls all those pieces out. So this is the basic pattern. You saw one where you're tearing into a single a single thing, and here you're tearing into something that is expected to occur more than one time. And so that's a quick summary of how you talk to XML in Python. Up next, we're going to talk about the other serialization format, JavaScript Object Notation.
Hooey. So there you go. There you go. Yeah, sorry about the phone call. Like I said, I know I said I wasn't going to stop it, but that was an important phone call for me to take. I'm a man of my word. I like to do what I say I'm going to do or not do, but I do it. So I do apologize for pausing it like midway through. But there's the video. Now we've heard it again, or for me it was again. But man, this stuff is some thick stuff here. But the answer is this, like we did yesterday. Moving on to JSON. All right. The following code print. My gosh. What? All right. Let's just get into here.
So now we're going to talk about the other serialization format, JavaScript Object Notation. Chances are good, as you
JavaScript Object Notation. Douglas Crockford discovered JSON Object Literal Notation in JavaScript.
go out there, you will very likely encounter more JSON than you will XML. Not that XML is bad. XML is better for rich and hierarchical documents, whereas JSON is best for just pulling data out of a system and moving it between two systems with the minimum of fuss. This is Douglas Crockford. I have a great interview from him. He's a funny guy, very, very smart. He claims he didn't invent JSON, he discovered it, because it really is based on the literal notation for JavaScript. And it actually looks a lot like the Python literal notation for objects and for lists. Now, Douglas Crockford is quite a sense of humor. He wrote this book called JavaScript, The Good Parts. That's the little one right there. And then JavaScript, A Comprehensive Guide. And the sense of humor is all the stuff that's in JavaScript that's not too useful. And while this is sort of a tongue-in-cheek, it also is trying to say that JavaScript, what Crockford is really saying here is JavaScript is a great language as long as you avoid the tricky bits and sort of keep it very, very simple. And JavaScript is indeed a great language. But JSON comes from JavaScript. You can read about JSON at json.org. JSON is not an international standard. It's not like an RFC. It really is. Douglas Crockford decided to register json.org and typed in some pages, and people started reading it and people started using it. And partly that was because it was truly derived from the JavaScript JavaScript literal syntax. So we're all ready to code.
JSON represents data as nested lists and dictionaries. For JSON, data, name, Chuck, phone. Wait. Oh, so phones, it starts there, ends there, type. I don't know what that means. Number, email, hide, yes, so it just hides it, info, JSON, dot loads, data, print name, info, name. Wow. Let's just watch what he says, I guess.
Here is some Python that's going to process some JSON. Keep it straight. Python, process JSON. So again, I'm using the triple quoted string here. Now you'll notice the syntax that we are using is not angle brackets, but instead curly braces. And so the curly brace, and then within the curly brace you have key value pairs, name, colon, Chuck, and the key, colon, value. And both sides have quotes. You can also have objects within objects, curly brace, key value pairs, key value, key value. Looks a lot like Python. And then you can do this. And so this is a structure that has one key value pair that's a string, another key value pair that's an object, another key value pair that's an object, and then these are key values within those contained objects. So this is a string that again probably was retrieved across the network from some other place. And we're going to...
What? That's all a string? When you described it as key value pairs, that clicked for me. I understood that. I get that. Name, Chuck, number, hide, yes. Because that's like a, I guess like a true false sort of thing. Or like a yes, no thing.
We're going to pass that string into...
I don't get how it's a string. All that's a string? I guess so. Just in terms of the type of data that it is.
You know, the JSON library load S. Load S stands for load from string. So it reads this, parses it, looks at all the white space. White space, again, doesn't matter too much here, unless it's in between double quotes. The white space doesn't matter. And so it parses it and then returns us a dictionary. So the thing that's different about JSON is that its structure and representation are simpler than XML. So in Python, everything either comes back as a dictionary or a list, or a dictionary within a dictionary, or a list within a dictionary, but it's all dictionaries. It's not a separate structure that you have to do gets and finds and find-alls and lookups. So it's right there. So when we get this back, because this is a curly brace, info is a dictionary. And so we can just use the standard syntax of Python. Info subname. Well, that will bring... Let's clear this.
Be Chuck, right? Name
So
Chuck.
info subname, we'll go find Chuck. So if you compare that with the XML, that's just a lot easier. Now, when we have info sub email, that's this thing. So info sub email is that thing. And then sub hide is this. So that's what comes out here.
Whoa, wait, what? So print hide, and then it would be what?
Okay, so it's really nested dictionaries and lists. We haven't seen a list yet, but this is a set of nested dictionaries that it parses. And it's equally simple in other programming languages. This...
Oh, so this part's confusing to me. Print hide, or hide, no, that's fine. Hide info email. So that's hide yes, and then hide, which is just the yes bit. Okay. Yeah, I get it, I guess.
Equally simple in other programming languages. This is a little more complex version where the outer element is a square bracket, which means it's going to be a list.
Oh.
And so we have a list of 1, comma, 2 things. So this is a list of 2 dictionaries.
Wait, what do you mean?
So this is a list of 1, comma, 2 things. So this is a list of
okay.
2 dictionaries. So there's 2 dictionaries inside that list. So again, we take this string and we load it into, use the JSON parser to read the string and give us back, in this case, info is a list. It's got 2 items. If we print out info, it'll give us 2. And we're going to iterate through. And so if we're going to iterate through, item is going to first be this, and then it's going to iterate to this. And it's going to print out item some name, which is going to print out Chuck, item sub ID, which is going to print
what?
item is going to first be this, and then it's going to iterate to this. And it's going to print out item sub name, which is going to print out Chuck.
Oh, item sub name. Okay.
Item sub ID, which is going to
Item sub ID.
print out
001.
001. Now you'll notice that there is no attributes, and that's because JSON is simpler.
Attribute. Item X. What?
But we can have
Oh, like we don't actually have to put in like the type or whatever? Like type.
have the X just as another item. So we say item have that there is no attributes, and that's because JSON is simpler. But we can have the X just as another item. So we say item sub X, and that's going to print the two out.
Attribute. X. 2. Okay.
And then it'll iterate to the next one, and it'll print out the same thing for those guys. And so JSON is simpler because you can't represent as complex a data structure, or you have to compromise and map it into a simpler data structure, but then it is lists and dictionaries. And so once you've got it parsed, it is easier to understand and to make use of. So that was quick. So that's, you can't represent as complex a data structure. Iterate to the next one, and it'll print out the same thing for those guys. And so JSON is simpler because you can't represent as complex a data structure, or you have to compromise and map it into a simpler data structure, but then it is lists and dictionaries. And so once you've got it parsed, it is easier to understand and to make use of. So that was quick. So that's partly why everyone likes JSON better, is once you have come up with a format that you're going to send it back and forth, it's easy to make it and it's easy to read it. Now what we're going to talk about is sort of moving up a level. If you've got all these data formats and URLs that you can hit to pull those data formats down, what approach and URL, it's easy to read it. Now what we're going to talk about is sort of moving up a level. If you've got all these data formats and URLs that you can hit to pull those data formats down, what
Pull the data formats down?
Data formats and URLs. What we're going to talk about is sort of moving up a level. If you've got all these data formats and URLs that you can hit to pull those data formats down, what approach do you do as you start to construct applications that increasingly go from a single application to a networked application?
So he's talking about like data structures like I'm not 100% sure, but like URLs to pull data from data structures, you know? I don't know. It's still a bit confusing to me too, but I'm still kind of confused on what a data structure is. Because is that like a schema? Let's listen to it again.
You've got all these data formats and URLs that you can hit to pull those data formats down.
Or data formats, not data structures, my bad.
What approach do you do as you start to construct applications that increasingly go from a single application to a networked application?
Okay. Let's kind of push on. I mean, my thinking is that we can try and, if there are holes in our knowledge later on, which there will be, we can try and fill those holes. You know, I mean, later on. So I'm not like crazy stressed about it now. Data structures and stuff. I said it again. Data structure. What do you say? Data formats.
They go from a single approach to you formats down, URLs that you can hit to pull those data formats down.
Just the terminology, like how he uses it, like to pull them down, like that's. I'm not gonna stress too much about that because I don't know what he's referring to. Does he mean like downloading? No, not downloading them, but like I think it has to be a schema, right? Like if you have like a program that tries to mess with data on some URL. Data format. Good to make sure that everything is like kind of abiding by the same rules. Data format. On my brain. There's a lot going on in my brain today. I'm going to move on for now. I'll probably try and address it later. What will the following code print? Import JSON, data, ID 02, Quincy, ID 97, Marugish, info JSON loads data, print info 1 name. So these are brackets, right? So that's a list of dictionaries. So this is it's a trick question. It's a trick question because it's 01, right? 0, this is 0, this is 1. So info 1, so info is the JSON loads data, right? This is the data. Info 101 name. So it's Marugish. It's a trick question. Yes. I'm pleased. Excellent. All right. That's going to do it for today. We are caught up now. I know we only did we only did one new video today. But we're caught up now that we have heard properly the video from last night that you guys couldn't hear fully before. So I'm going to go. I'm going to finish this editing down here, and then I got the new, not the new, but it's new to me. I got the thick boy compendium for Invincible. And so I'm pretty excited. I'm gonna I think start it today. We'll see. But yeah. Not that that was relevant to anything that we're doing here, but yeah. So thank you guys so much for watching. If you enjoyed this sort of content, please like and subscribe and leave a comment down below if you have a prayer request. I'd love to know how I can be praying for you guys. But love God, love people, and I will see you guys soon.